We'll now look at one additional example in this section on confidence intervals. Again, before we get to our example, let's review the formula that we'll be using. So our example reads, a researcher wants to estimate the number of days it takes an automobile dealer to sell a particular car. We have a random sample of 50 cars. All right, so I'm going to go ahead and make a note of that sample size. We're told that the cars have a mean time on the dealer's lot of 54 days. So again, that refers to those 50 cars. A random sample of 50 cars had a mean time on the dealer's lot of 54 days. So that is my sample mean. We are told to assume the population standard deviation to be 6. Now, this is very nice of this problem to actually tell us that we are dealing with the population standard deviation. That takes that question off the table for us. We know that we have the population standard deviation because it gave it to us as that. And then the question says, find the 90% confidence interval of the population mean. So I'm going to go back to my formula, and at that point I realized that the z-score for 90% is going to be 1.65. Okay, so we're going to plug that in for the z alpha over 2. All right, so let's go ahead and set this up and do our calculation. So again, I'm going to write my formula down. And then I'm going to plug my values in. So for the x bar, I'm going to plug in 54. For the z-score, I'm going to use 1.65. The standard deviation, we have 6. Sample size, we have 50. And then we're going to have the same thing on the other side, except we'll have a plus instead of a minus. So once we have it set up, we can then go to our calculator and type it in. Again, nothing special. Type it in just like it appears on your paper. All right, so rounding to 2 decimal places. The left-hand side is going to be 52.5999, which is going to round to 52.6. And the right-hand side, 55.40. Okay, so again, remember what we have done. We have taken the mean of the sample. We've used it to make a prediction about the mean for the population. So we know that the mean for those 50 cars was 54 days. The mean for all cars should be somewhere between 52.6 and 55.4, and I am 90% confident that it is. So that leaves a 10% chance of error. So it's possible that it's not between those two, but 90% of the time it is. Now, the other thing that I want to take just a minute and show you is what happens if the percent confidence is not one of the 3 that are given in our formula. So what I'm saying is if you encounter a problem, and you will see this in your homework, where the percent confidence is not 90 or 95 or 99, you need to know how to calculate that z-score. So I'm going to take one of these I'm going to take the 95% one, and I want to show you where it comes from. So 95% has a z-score of 1.96. And so I just want to show you how that's calculated so that if you need to calculate one, you can. All right, so remember that our z-scores are based on the standard normal distribution curve. And this is no different. These z-scores that we're dealing with in these problems are based on z-scores. Okay, so I'm going to go back to this example for just a second. What is happening is that you are taking your mean and you are building an interval around that mean. So on the left-hand side, you're taking your mean and you're subtracting something off. And when you do that, you get the 52.6. So your mean was at 54, you subtracted this thing off, and you got the 52.6. On the other side, you're going to take your mean at 54, and you're going to add the same thing to it, which is going to make your number go a little bit bigger, which is what we're getting right here. Okay, so I'm going to take that same idea back to my curve here for a second. All right, so here's my mean. So when I subtract something from the mean, it's going to push me back to the left. Okay, so I'm going to draw myself a line, and this is going to be what happens when I take my mean and I subtract something from it. If I take my mean and add something to it, it's going to push me to the right. So I'm going to draw a line there. So this interval that we build is represented by this shaded region. Okay, so when we say that we're 95% sure that the average falls in between these two, there's a z-score here and a z-score here, okay, we're saying that there's a 95% probability that we got that interval correct. All right, so I know now that the area of the shaded part of this curve is 95%. Or 0.95 or 0.9500, which is probably the best way that I want to have to look at that. Now, remember that you added and subtracted the same thing on both sides to get these lines. So these sides should be equal. The left side and the right side should be equal. So if I take 95.95 and I divide it by 2, that gives me 0.4750 and 0.4750. So I'm basically taking my shaded region, which is 0.9500, and cutting it into two equal places. Now, if you go to your table and you look up that 4750, now remember that that's an area, so you're going to be looking it up in the middle of the curve. You should find that there exactly, 4750, and if you put your finger on the 4750 and then go across and up, what z-score corresponds to that? All right, you should be seeing a z-score coming in at 1.96 or at negative 1.96. Okay, and that is where we get that value. All right, so let me show it to you one more time. I'm just going to walk you through, and we'll go quickly on this one, but I'm just going to walk you through it one more time. So let's say that we have a problem that asks us for the 88% confidence interval. And I would need that z-score to use as I work the problem out. Okay, so what I'm going to do is draw my curve, and I'm going to section off this middle portion. just like we did in the first example. Now, I know that the total area of the shaded region is 88%. And I have it split into 2 equal parts. So this part is 0.4400, and this part is 0.4400, because 44 and 44 make 88. Now, the only thing I have to do is find the z-score that separates shaded from not shaded. So going to my curve, I'm looking for, in the middle of the table, 0.4400. Okay, so this one is not in the table exactly. So I see, when I look at my table, I see 4394, and the next one is 4406. Okay, so those are the 2 that it's in between on the table. So which one is it closest to? Because that's our rule. We use the closer one. But 4400 is right in the middle. And so what does our rule say to do in that case? It says to go with the larger one. All right, so look at your 4406, put your finger there, and read off your z-score. So 1.56 will be our answer. And so if you were working a problem that was asking you to find an 88% confidence interval, you would use 1.56 for your z-score. So hopefully that helps you as you're working problems. If they don't give you the 90, the 95, or the 99, helps you to be able to calculate that z-score that you'll need.